In this video, we're going to look at infinite limits. And there are two ways that we can have infinity showing up in our limits. One of them we'll refer to as limits at infinity, and that's going to be where we consider the limit as x approaches infinity of f of x, or the limit as x approaches negative infinity of f of x. And if these were to equal some real number, what this means is that as x, I'll say the working definition first, goes further and further right, unboundedly keeps going right, f of x approaches L. And this one, if we're going towards negative infinity, x is going further and further left. So as x goes left, f of x approaches L. Now this is just sort of the working definition. We can get our answers in most courses from this, but to get more specific, I'm not going to sort of write in here, but I'll say it. If I want to figure out what this is, basically all I'm saying is no matter how close I make sort of an epsilon bound around this L, I can go far enough right, choose some n value, that everything further right is close enough to L. And similarly, for this one, I can put some arbitrarily small boundary, epsilon boundary around L, and I'll be able to choose an x value that's far enough left so that anything farther left will work for that. Will be close enough to that L. So one example of this, I am considering this function, and I want to evaluate the limit as x approaches negative infinity and limit as x approaches positive infinity. Now one option would just be to make an input-output chart, and for this one use negative numbers like negative 100, negative 1000, until I get negative enough that I see what the answer should be. And I could do this same thing here, except start at large positive numbers, make it more positive. The other option is to consider the graph, and that's what we're going to do for this. So here is the graph of that function. The first thing we're looking at is if we consider going to the left. So I'm going to put a point on here. And I probably should have set this up before, but I'm going to have it show me the value of the point so I can see the coordinates. And I can see over here I get some other values, but as I go far left, it doesn't even have to get that far left. You see the y coordinate is what we're going to see the limit is, and it's going closer and closer to 1.6, 64, 65, 66, and now, no matter how far left I go, I'm at this 1.67, and I can turn it so that I round further, and same thing, sort of increasing to this 1.6 repeating. So what does that mean for our limit? Well, that means that this limit will equal 1.6 repeating, which is the same thing as 5/3, which should not be surprising because I see a 5x and a 3x. The other side is a little bit different. So let me take this point and drag it over to this side. Now, so far from what I can see on the graph here, it doesn't seem to be settling down. And that actually doesn't get any better as I look further right. It continues to oscillate almost perfectly between -1 and 1. So as I move the point further right, you can see, okay, it goes up near 1, goes down near -1, goes up near 1, and this continues forever. So what does it settle down to? Well, easy answer. In this case, because of the oscillations, this limit does not exist. I need to have it settle down to a single value. It doesn't matter that I'm trapped between a little bit less than -1 and a little bit less than +1. I'm not settling down to a single value, so this limit does not exist. The other way that we can see this is if we are considering limits of infinity. And how this works is as follows. If, as x approaches some value, and it can be from the left or from the right as well, f of x gets unboundedly large or unboundedly negative, then the limit as x approaches that value of f of x will equal infinity, or if it gets unboundedly negative, negative infinity. And let's look at an example of that. So we'll consider g of x equals 1 over x. And that function is going to look like this. Now, as we can see, as I'm approaching 0 from the left, my function is getting more and more negative, and unboundedly so. If I were to sort of zoom out vertically, you can see it doesn't matter how far down I consider, the curve is going down there. Okay? So the limit as I approach 0 from the left of 1 over x will be negative infinity. And, for the same reason, as I approach from the right, I'm approaching positive infinity. It's going up. So this one is equal to positive infinity. Now, since these are not approaching the same infinity, this limit does not exist. If they both approached negative infinity, or they both approached positive infinity, that limit would exist. So if instead of having 1 over x, I had a similar function, 1 over x squared, now you can see from the left it's approaching positive infinity, and from the right it's approaching positive infinity, and that means that our limit will be positive infinity, as well as both of our one-sided limits. Another thing that's worth noting that I've seen happen before is this. If I consider a function that gets steep, like, just say x to the 5th, and let's say, what's this limit as x approaches 2? It looks like it's going up very, very high, but when we actually consider what happens, it doesn't. I need it to go up unboundedly, and in this case, it doesn't go up unboundedly, it actually goes through this point to 32. So be careful. Just because you see something that's going up and going up steeply does not automatically mean that you'll have a limit of infinity. Alright, I hope this helped out. If you have questions, feel free to comment below.